time for another draftphysics.com, debatephysics.com also. But the debaters, there's nobody else show up who isn't basically a coward, who just evades the arguments made and propagandizes, distorts and perverts to force a fake and phony impression of the truth. So they're all very dishonest. So I'm going to show you what real science looks like, and they're going to keep doing what the fakes and the phonies have to do, which is evade all of the arguments and distort and pervert what information we do have. So first subject will be a comment okay, made by, again, just another cowardly troll who can't use a real account, so it's all this sock account bullshit. They won't be accountable for the bullshit they type and say. And then we'll do a Despar. We'll talk some more about one of his experiments that doesn't indicate what he's trying to present it as, and in fact does validate the counter argument if understood in the proper context of the real physics. Okay, so I'll just read this. Gravitational, this is a quote from some source. Okay, so I made the argument that the Eddington experiment hasn't been repeated successfully. All the earthbound attempts have been rubbish, essentially always something wrong angle to the sun, too weak an eclipse, or some data bullshit, some distortion problem. Not a simple experiment, frankly. It wasn't in 1919. Alright, and I've pointed out the simple fact that in Eddington's own journal, he made it clear that everything that could go wrong went wrong. It was raining 5 minutes before he was to take his the eclipse. Obviously the atmosphere full of water droplets. It was just really the worst conditions possible. And he pointed out that his data was 10% of what he was hoping for. He was hoping for 10,000 stars per slide. He got 1,000. That did insanely terrible, awful degrade in the quality of the experiment. It's like shrinking the telescope by 1/10 of the telescope. A 12-foot telescope turned into a 1-foot telescope. Huge degrade, gigantic. Stated also that he wouldn't stake his life on these results because of that horrible data. And yet, 6 months later, after analysis and bullshit and shenanigans, which is already part of the record that glass slides disappeared, there was conflict between the two different parties that they were using data from. Both of them had terrible, catastrophic failures. The one in South America, all their slides got degraded by the exposure to water. But anyway, so it was just garbage as a scientific experiment, yet the New York Times headline was Einstein proven right. Alright, so, and we're supposed to believe that light is twice as bent of any other material object in the universe, and the simple truth is there's no comparable quality data or experiment that demonstrates that it fills the void left by that crappy experiment. Fact. Alright, so in that context, let's read this silly quote. Gravitational deflection of starlight around the sun during the 1919 total solar eclipse provided measurements that confirmed Einstein's general theory of relativity. So we know that didn't happen. Okay, that's really not what happened. It was a shitty experiment. The data was crap, and this whole thing is just bad science. You don't take a terrible experiment and present it as a pristine, everything went just right, and we have perfect data. That's just lying, frankly. Alright, and then he says, we have used the Hubble telescope to measure the analogous process of astronomic microlensing caused by nearby stars. So this is a lie. It doesn't have anything to do with the Eddington experiment. Obviously the Eddington experiment, if anybody understands anything, I really shouldn't even have to do this, but I'll do it. It's just a fact that this is how the experiment has to be done. You have to exclude the corona of the sun as a viewing point. So if you did the experiment through the corona of the sun, you'd have every expectation that you would get some lensing in every single location you could possibly go to, that you would get some image data. Now the fact is you'll get a scattered image, so you won't be able to see anything with detail. So if there's something round, yeah, you'll see it because you can't screw up round. But if it has a left and a right, it has a little spot on it or something to indicate its character, that data will be destroyed by scatter. So you won't get image data, but you will get the idea of energy data. So you'll see something, okay? And the whole point was Eddington had to go out here, okay? He would have liked to do the experiment closer to the sun and be in gravity that would be 4 times stronger, but he actually has to use stars that are out here where the gravity is 4 times weaker than at the surface of the sun. But it's one of the facts of the experiment. Obviously the experiment can't mean anything if you're allowing particles to deflect the light rather than see it bent by actual gravity. Now obviously some experiment we do from our planet to some place a light year away, here's a sun that we can't even see beyond just being round, and then some objects behind it, and we're going to claim we saw the lensing of some object behind. Well, obviously the corona of that sun hasn't been evaded, so obviously there's no reason to think that you aren't just seeing the lensing created by the scatter of the light. So it's a pretty weak argument to make when talking about gravitational lensing in the cosmic, very distant objects lensing very distant objects, and the huge difference between a very close object like our own sun lensing light of a very distant object. Very different phenomenon, very different experiments, and it's just such a lie for them to say this is analogous, that this is a replacement experiment. It's not a replacement experiment. So just more molesting of the truth. Okay. Alright, microlensing caused by a nearby star. The white dwarfs Stein 251b. As Stein 251b passed closely in front of a background star, the background star's position was deflected. So again, that's perfectly possible if you're not accounting for the fact that you're looking through some dense field of scattered matter that the sun is producing. Okay, relativistic deflection of background starlight measured the mass of the nearby white dwarf star. So just more fake physics in the sense that you're using an assumption that's incorrect. So this is like when they say the universe is expanding because photons are redshifted with distance, when there's lots of explanations for why photons might be affected by traveling longer distance that don't involve the creation of fake, phony, free space. The universe keeps making space more space, and things keep moving away from each other without moving any velocity, but they're moving away from each other. I mean, ridiculous assumptions. So you're just proving my point. The point in the video made was that the science is really poor, that they can't even figure out, like this again, these are arguments like pointy arrow can go deeper into something and it doesn't mean it has more energy. These are really stupid conclusions to draw, okay, and it's really bad science, and they're just bandwagon riding, Yahoo flag waving group thinkers, and this has nothing to do with what science is supposed to be, which is not be a group thinker, a god botherer, for example. And that's all they are. It's a religion. It's not science. Alright, so on to the Despar video experiment. Alright, so in some respects it's a simple enough experiment. You're just dropping objects and trying to see how much energy you can measure them producing at impact. That is, trying to collect the energy of their impact with some mechanism known to be fairly reliable in collecting that energy. So he's dropping objects onto a rubber band, and the rubber band is presumed to be a fair cop in how it measures. Now, unfortunately, he hasn't tested it at all. So he hasn't put weights on the rubber band to see that it's nice and linear, that 1 pound does this much, 2 pounds is twice as much, 3 pounds is 3 times as much, 4 pounds is 4 pounds as much. So he hasn't made any effort to test this detecting device. Alright, so that should be stated first. Alright, and now there was lots of other little flaws, but he's made it better and better. But there's always something that's still obviously not so good. Alright, so I'll just do the little slow motion thing here. I should be able to finish it off. Yeah, there it goes. So it'll go down to a certain point. So now you can see the card sort of through this stupid shareware software crap he's using. Anyway, you can see he's using a little card to hit the rubber band, the same with both experiments, so there isn't any change in how the energy is absorbed, which is good. The bad news though is it's not on the center of the object, so obviously now there's all kinds of friction created as soon as there is an impact, because you're not hitting on the center of mass, so the ball is going to tend to rub against that stick that the ball's sliding down. So that's not too good. Alright, so as you've seen enough of the experiment, you can see in the time it takes to absorb it that a 1 mass dropped 4 distances versus a 2 mass 1 distance. So those are two things that are supposed to have the same momentum. And the fact is that if you measure the time it takes for the energy to be absorbed, the thing with twice the velocity happens in 1/2 the number of frames. So it comes out quite indicating of 2 to 1 in terms of how fast the rubber bands absorb the impact. So the 2 mass dropping 1 distance, 1 velocity. So the 2 mass at 1 velocity, say, takes 10 frames to compress the rubber band. The 1 mass at 2 velocity takes 5. So that's very 2 to 1 right there. Alright, now the outcome results he got are a little bit off. Okay, so let's just get rid of this, but you won't need this anymore. So let's just illustrate it. So you have a 2 mass, and it's going to fall 1 unit of distance, and it'll have 1 velocity. So it's a 2 mass and a 1 velocity versus a 1 mass. Now it's going to fall 4 times the distance, but it's only going to have 2 velocity. It's only going to be twice as time in the gravity. So it only collected, frankly, 2 units of force, and it's half the mass. So same momentums. And so their prediction is that this should be twice the energy at impact. And so the results are, say if this deflected the deflector by 5 centimeters, this one was 6 centimeters. So it's a little bit off of being equal. Now you could account for that by that uneven card, a little more friction, the heavier mass he's doing this way, so we could just illustrate it that way. He's taking 2 of some object and dropping it. So the potential for more friction is kind of obvious in the sense that you have 1 mass affecting another mass, and that mass is unevenly absorbing the energy. The energy isn't going through its center of mass, so obviously it has to tilt. Alright, anyway, so the real results. These are the real results. And what he does is assumes, that the standing weight of this object, that is its static weight, has to be subtracted from these distances. So if this weighs 2 pounds, you subtract 2 pounds worth of motion from the end result numbers to contrive a result that is further off. Okay, and it will be further off. Still won't show twice the energy. Alright, so their theory says that this has twice the kinetic energy. Alright. And obviously these results aren't anywhere near twice. Okay, not even close. And there's good reason to know you can't do that subtracting of the static energy. So we'll do that part. Alright, so if you can understand that gravity is in fact a time-dependent force, that if this was ice, and the faster you went across this ice, the less pressure you'll put on the ice per inch, and therefore not fall through the ice. So you can traverse thin ice by just increasing your velocity, and to some obvious point where there's a limit, I suppose. But frankly, it really isn't, because the faster you go, you're really taking off, because the curvature of the Earth, you're going faster than the Earth is curving, and therefore you will essentially become airborne and not touch the ice at all. But anyway, so if you understand the principle that gravity is basically a time-dependent force, it's 9.8 meters per second per 1 second. Alright, so it happens in chunks of time. And so these experiments are happening in a fraction of a second, tenth of a second, 20th of a second, 30th of a second. The whole thing happens very quickly. So the static weight of the object can't actually happen if it doesn't take the necessary amount of time for it to read its mass. So we know that if I travel the distance in 1/10 of a second, I'm going to be putting 1/10 per segment of distance. So if I did the full second on one hunk of space, and I do all of these spaces, I do 10 of those spaces in the same time, that I'm going to have 1/10 the pressure. So understanding that the static weight of the masses really doesn't have anything to do with the experiment, because we know if I did this experiment where I put a mass on, let's say I didn't put the mass on. Okay, so there's no mass, there's just a compression of a rubber band because I pulled the rubber band down with a string. So I pulled down and created 10 pounds of force. I can't put a 1 pound object on here and this won't read 11 pounds. Okay, because I have 10 pounds of force already in there. I have way more force than the force of the object, and the force is now wanting to go this way. So I can't add weight to an already compressed rubber band. So it's a good reason to understand that the static weight is irrelevant, because the momentum has already compressed the rubber band much deeper into a much higher force, and the 1 pound just can't weigh anything. It can't increase the force because I'm already way heavier than the object I'm adding. So, it would be best to probably do all of these experiments linearly, okay, left to right instead of up and down, to take gravity out of the experiments. But you can't do that with rolling objects, because rolling objects are still in gravity. So you do have to essentially launch objects, and you have to launch them horizontally, not vertically, to do these kinds of experiments in a fair manner, and we just don't have those experiments. So the simple argument I have made over and over and over again is that there is an actual speed with which you will have the same momentum as your static gravitational weight. Alright, so and it's 1 mile an hour-ish. So at 1 mile per hour, I could take any object and hit it into a scale, put horizontally, and I'll measure its gravitational weight. So I could push an elephant at 1 mile an hour. It will weigh, 1,500 pounds. I push a mouse and it'll weigh whatever, 15 ounces or something. So I can, no matter what object I put on, I move it 1 mile an hour. So the argument is that every centimeter, 1 centimeter of drop approximately, might be 10 millimeters. I mean it might be 8 millimeters or 10, something in that range, produces a doubling of your mass. So if I drop something from 1 centimeter, it will weigh twice its weight. Now its velocity is going to be very slow. It's not going to happen, the whole experiment's not going to happen in 1/10 of a second. So there'll be time for gravity to add its extra mass, and it's also adding a mass that's the same as the static mass. So the momentum isn't greater than the weight you're trying to measure, and so therefore the momentum of the drop hasn't already consumed the capacity of the measuring device to measure it. So it will actually weigh twice. And the argument is that if I did the experiment horizontally, it won't weigh twice its mass. It'll just weigh the 1 times its mass, because of the fact its mass and gravity. It will be equal to that because you can't combine the forces again in the horizontal mode, so you won't get any static weight. So you can only measure the static weight when you haven't already created an opposite force that's greater than the force you're trying to measure. And as soon as you put in an opposing force that's greater than the extra mass you're adding, you won't get any reading on the scale, no increase reading in the scale. So that's why the idea of subtracting the static weight is wrong and incorrect and false, and it breaks the experiment, doesn't make the experiment, and it just creates a distortion and a perversion of the data. So the fact is, let's get to the facts. Alright, so I guess I should, as context, point out that this is the kind of stuff, their science hasn't bothered to even think about. So there's a simple argument that you could absorb energy using a spring, and the idea is that it's pretty consistent in the fact that you do get it to collect energy and release energy, if the spring is connected. So we can watch a spring oscillate back and forth, and the assumption is the energy is trapped in the spring, and it just will oscillate a very long time, in a perfect circumstance. Now the Falwell character has done this with a carbon rod and demonstrated that the vibration, the energy, can go quite a long time. If there's no heat created or other way of consuming the energy, it will oscillate a very long time. But what they haven't thought about that is if they did actually launch a mass, so the mass isn't constantly connected, and you're actually launching the mass, that the problem is that as the spring is moving, it has a mass itself. And its motion, is energy that has to be taken out of the energy you put in. So the in energy has to not only move the object, it has to move the spring. So when the object's leaving the spring, it's going to be going, say, 30 miles an hour. Well, the spring is still going 29, So the spring itself still has a bunch of forward energy it hasn't used up yet. It still has energy to give, and there's nothing to give it to. So the spring will start to oscillate back and forth, showing you the energy it still has. And so no physicist has brought this up that I know of. Not a single one. And it's critical to a bunch of experiments they do where they push things around with compressed springs, because the obvious implication of it is that the spring steals a huge amount of energy when you launch light things, and it steals very little energy, okay, when you launch heavy things. So it disproportionately gives the energy back to the object. You can understand that if it's only going 6 miles an hour, then the spring's only oscillating at 6 miles an hour, where the spring over here could be 60 miles an hour if I'm comparing a 10 mass to a 1 mass. Huge, gigantic difference in how much energy, momentum, is stuck in the spring and didn't get into the object you were launching. So it's not like some kind of automatic presumption that no matter what mass object, no matter what the mass of the object is, the spring gives me the same total force. The total net force is exactly the same, when clearly it's not going to be the same. Alright, so nobody's brought that up. Nobody. On the face of the earth, nobody's going to find any documentation where somebody points out springs collect energy really well. They don't give it to objects very well in terms of consistency. So as a context, just understand that's the real physics. Real physics is seeing these things that are true, okay, and recognizing them. So in this case, Despar is taking numbers that are 5 to 6, and he's perverting them by assuming that somehow static mass is part of the object's momentum when it isn't, to create numbers that are more like 6 to 10. Okay, so it looks more like it's twice as much energy. Okay, when no, the actual data is this. So when the statement's made that they claim that the object, the lighter mass going the doubled velocity, has more kinetic energy, twice as much kinetic energy. The half mass going 2 velocity versus the 1 mass going, the two mass going 1 velocity versus the 1 mass going 2 velocity. They say the 1 mass going 2 velocity has twice the kinetic energy. Well, that's not what the actual numbers say. Okay, the actual numbers are nowhere close to 2 to 1. So it demonstrates a complete failure of the experiment to confirm their prediction or assertion regarding the function. And it's only through perversion of the numbers, the actual fight, the actual what happened in the experiment. So again, Leibniz he didn't put any qualifications on his statement that 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet. He didn't say, well, if you subtract the static weight. He didn't say any of that. Okay. So the impact energy is the impact energy. If you're going to change the numbers and pretend the impact energy was something else, we know that this landed with, say if this was pounds, this landed with 5 pounds of force. This landed with 6 pounds of force. Okay, that's what they landed with. They didn't land with these synthetic fake numbers. Alright, so that's probably enough of a statement. So, it's nice. Look, it's great. People do experiments. Look, another thing, there's little things you can observe in the experiment. You say, okay, you didn't observe them. I did. I mean, that's not my bad. That's your bad, frankly. Alright, so another flaw in his setup is that he has these bars, okay, by which he has stretched the rubber band across. And a problem is that the bars move, okay. So when the impact happens, it's not just that the rubber band deflects, it's that the bars bend in, okay. So their elasticity is part of the experiment, and there's no measurement of that, and there's no rule saying, okay, when the event happens in 1/2 the time, right, the faster event is actually happening in 1/2 the time. It's a pretty big difference in their velocities, 1 to 2. It's a doubling of the velocity. Obviously, when you double the velocity, you might be changing how well those steel bars can absorb and take energy out of the experiment. So that's another variable that just, sort of makes a mess out of the reliability. It's much like if I was to do a scale experiment and I put the scale, okay, that's going to read my mass, and I put the scale on foam, so it deflected, the foam compressed as I put the object on the scale. Obviously the scale is not going to work. It's not going to give you an accurate reading anymore. So these are important details. Again, they find these details obnoxious. They find them petty. They find them uninteresting. They find it to be some sort of, oh, you're just trying to find excuses to escape our perfect science. And that's what they're trying to argue, that these junk experiments are perfect science, just like they're trying to defend the Eddington experiment not being repeated from space, which is an overtly unscientific thing to do. Anyone interested in science, and especially interested in the bizarre statement that light is twice as bent. No other object is bent twice as much. Just light, photons, one of the smallest things in the universe, is somehow bent twice as much as anything else. That's a bizarre assertion. And they don't want good, hard evidence. They don't want to see it for themselves. They don't want to see an actual object being moved from its position, us observing it as a mirage. And the only experiment that's going to do that is this Eddington style. That's the one that does image data, so you're not going to get confused by the corona or by scatter or by something else. If the image is retained, then it can't be anything but gravity. Now, when they do the galactic ones, when they're the lensing, the galactic lensing, you can know how much of a fraud that is, because Einstein pointed out how there'd only be a tiny, tiny sliver of region where you could duplicate a pattern. So if I make a pattern that's these two things, so I'm saying they'll often say that the object is here and we also saw it here. That can't happen by Einstein's own argument, because the gravitational lens, at least Einstein was smart enough to concede, the gravitational lens is bent the wrong way. Things in close get bent a lot, and things on the outside get bent very little. And a magnifying lens does exactly the opposite. It bends stuff on the outside a lot and bends the stuff in the middle very little. So exactly the opposite of gravity. So if there was to be lensing, it would only be in a tiny, tiny region. So no object that had any size could ever be imaged. You would never see something that has more than one part, because the image data would be in only one tiny little frame of space. So anyway, there's all kinds of, these are just facts, details. They just couldn't care less. Okay, and there's all kinds of evidence that these Hubble images are highly processed, and there's all kinds of evidence that these are erroneous artifacts of the process of processing these images, that these errors are made. Anyway, so that being said, and some of them are so, they're obviously blurred, almost like they're moving. Which also is, well, that can't be happening. But anyway, yeah, so it's probably enough of an argument. But, the real science is these facts. You put a scale on foam, it's not going to read right. You do certain things, the experiment's not going to give you accurate data. And, again, they're hostile to any effort to understand that. And look, in the basic argument here is we know they are wrong, because we know, anyone logical has to know, that putting 1 pound on a scale can't be 1 unit of energy. And when I add a single more 1 pound, I put 1 more pound on the scale, I can't have 4 units of energy. That can't happen, because I just have 2 units of weight. And that's all I have on a spring, is 2 units of weight. I don't have 4 units of weight. I can't have 4 units of energy. Not possible. That would be free energy. No. Doing this and calling it 1 unit of energy, and then saying, well, I just did it twice. Now that's 4 units of energy. It's ridiculous. Okay, so till the next time, and such, and so forth, and whatnot. I can only do my job. The fact that humanity, viewing these videos anyway, the segment of humanity viewing these videos are so pathetically dishonest and can't make a single honest statement. Again, not one of these trolly lying sacks of garbage like Piro would even concede that of course NASA should have attempted the Eddington experiment from space. There's 400 times better resolution, you only need a mediocre camera, and you don't need an eclipse, and it only takes 5 minutes. 5 minutes of camera time. 5 minutes. And they haven't even attempted the experiment? You could argue it's a $10,000 experiment at best. I'm sure I could buy satellite time, a camera's satellite time, for probably $10,000 or $15,000 a minute. Probably a lot less than that, frankly. But anyway, till the next time, and such and so forth and whatnot. This is just garbage science. Propaganda for a religion full of totem poles. Full of holy ghosts.